Today we're going to talk about 3D graphing. What is a coordinate space, and how do we understand what we're looking at when we see a coordinate space? So here's an example of a coordinate space. You'll see your traditional x and y axes. I've dotted the axis. It's not always dotted, but sometimes it's dotted to show that it's below the xz plane. So each of the axes are still lines. The arrows point in the positive direction, and if your axes are constructed well, they should have labels on them. So if this is the positive x-axis, this is the negative x-axis, this is the positive y-axis, this is the negative y-axis, and you have to imagine perspective that z is coming out of the page here, and then that's going into the page. You can't think of this as a diagonal line. You have to think of this as here's in the middle of the page, and then here's coming out of the page, and here's going back into the page. We can plot points in this by doing something like this, going 3 right, 1 up, and then 2 out. This represents the point 3, 1, 2. Now, it's worth pointing out that not always do you see the x-axis horizontally, the y-axis vertically, and the z-axis coming out of the page. This is my preferred orientation of the axes, but it's not required that it be in this particular order. There are a few options. You could have x coming out of the page and y going to the right, and z going up and down, and this makes sense in terms of real life where you're looking at up and down being your z coordinate. You can think of this as think of this as the altitude of something, or the height of something. Sometimes it's technically possible that it would be x is up and down, y is in and out, and z is to the right. The important thing about the 3 axes is that they follow the right-hand rule. And in a Euclidean coordinate space, Euclidean meaning it follows the rules set forth by Euclid, the relative direction of the axes can be shown by the index finger should be pointing in the positive x direction, the middle finger should be pointing in the positive y direction, and the thumb should be pointing in the positive z direction. So physically take your hand, make sure that it's your right hand. If you're forgetting which hand is your right hand, I can't help you there. The pointer finger should be pointing in the x direction, middle finger in the y direction, thumb in the z direction. Go back to these and see, okay, now your pointer finger would be pointing to the right, so your middle finger would be up and your thumb would be out of the page. With this one, the pointer finger would be pointing at you, out of the page. The middle finger would be pointing to the right, and then the thumb would be pointing up. And here we have the pointer finger pointing up, the middle finger pointing out, and then the thumb pointing to the right. So any of these are acceptable as long as the orientation between positive x, positive y, and positive z follows the right-hand rule. In two-dimensional space, in a two-dimensional plane, we split the plane into 4 quadrants. In three-dimensional space, we split it into 8 octants. So what you're seeing here is each of 8 divisions of the coordinate space bounded by the xy, xz, and yz planes. So the xy plane is here. If you ignore the z-axis, if you look at all the points where z equals 0, that's the xy plane. And then if you ignore the y-axis, this is the xz plane. If you ignore the x-axis, this is the yz plane. So maybe I'll trace out the xz plane it looks like this. Now remember that a coordinate space, just like a coordinate plane, extends in all directions. So zooming in, zooming out, that type of thing is totally possible. But this is the XY plane. If you look at where each octant is, all of the first four octants are in the positive z direction. So here's positive z, and then here's positive x, positive y. That's octant 1. And then here's octant 2, 3, 4. So that's the same as the order of the quadrants, just we look at the positive z direction and then use the normal order of the quadrants. Positive, positive, negative, positive, negative, negative, positive, negative, all with positive z coordinates. Then the negative z coordinates have the later octants. So octant 5 would be a positive x coordinate, a positive y coordinate, and a negative z coordinate. Here's quadrant 6, quadrant 7, and quadrant 8. So all of these, 5, 6, 7, and 8, have negative z coordinates, and then they follow the exact same rules in terms of the order as 1, 2, 3, and 4 do. So let's just look at which octant each point is in. Because I see that the z coordinate is positive, I know that it's 1 through 4. And if I'm looking at this, 4, 4, 4, comma, negative 4, that's quadrant 4, so octant 4 is the answer. Here we see negative 7, so I know that the options are 5, 6, 7, and 8. Negative, negative means that this is 7. 0, 1, and 8. So this is 0 in the x direction. 0 in the x direction. 1 in the y direction, and 8 in the z direction. Actually, that's not in one of the octants. So this is on the YZ plane. And you know that it's in the YZ plane because the x coordinate is 0. If this were 1, 0, 8, then we'd say it's on the XZ plane. So it's on the plane that has coordinates of y and z. It doesn't have any x coordinate, or the x coordinate is 0. So this is a trick question. It's not in an octant because it's on one of the planes. Just like when we say in 2 dimensions, this point isn't in quadrant 1 or 2, it's on the axis. It's an intercept. Here, we have a negative z coordinate, so we know that we have these options. And then 5, comma negative 3, that tells me that we're in octant 8. And lastly, this is positive, 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 which you should probably be able to guess is octant 1. And it is, because positive z tells me we're looking at 1 through 4, and positive x and positive y means octant 1.